Quantum mechanics, machine learning, apparently rocket science as well. Apparently people actually do that rather than just say...
Real rocket science.
Real rocket science. Yeah. Then random stuff like neurofiction, so brain scanners and generated fiction. Mm-hmm. And anybody here use Apache Spark? Nobody? One? What? Whoa, scary. So underlying all of Apache Spark is Breeze, and underlying Breeze is netlib Java, and that man's responsible for it. So blame him for any of your bugs.
Yeah, using class path stuff.
And his proudest achievement does appear to be getting a Kerbal to the moon. And we have a photo. Yeah. We have a photo, although I've yet to have any proof that he's ever actually got a Kerbal back again. So we've done the straw poll. So a quick TLDR of what our talk's about. Ensime is not really an IDE, or at least from my point of view. Ensime is a toolkit for building IDEs and analysing code. So it gives a much higher level API over the fun things within the Scala language. But let's build it. I think we should. And I'm going to talk about that a bit later. So a quick overview of the talk. Sam's going to give a nice demo of Ensime in action, talk about the architecture, the ecosystem in our community, which is something we strive for, protocols, and then I'm going to talk about the future, so our current roadmap, the future, and so wrap up the talk. So, over to Sam for demo time.
Demo time, yeah. This is a little fiddly. Let's try to get it going. Okay, spacebar starts and stops. Excellent. Right, okay, so this demo, I don't really want to show you how to use Ensime. It's more just a very, very quick tour to show you some stuff that it does. It's not even everything that we do. So this is in Emacs. We're using a Darkula theme, so it'll probably look like IntelliJ to a certain extent. So we're just running gen Ensime here in SBT. That will generate us a .enzyme file, which is a definition of the project. This is what it looks like. So we just open up a Scala file here. This is just using standard Scala mode, major mode. Now we're starting Ensime. There's Ensime starting up in the background. And first thing that happens, well, we get a little funny fortune down the bottom, but first thing that happens that you'll see the semantic highlighting kicks in. It's quite subtle, but there are a couple of things that, it gets absolutely correct, whereas normal regular expression maxing will get wrong. Things like the types. All the types are definitely colored in the correct color. And we can tell the difference between values, variables, and method names. And of course, you can't tell the difference between those things if you're just using regular expressions. And you can see about 3/4 of the way down the page, we've got strings, and it even works inside string interpolated strings. So that's all good. Let's start typing some stuff. You get squiggly yellows for mutable state. And we've introduced an error here. Oh, you can't really see it too well, but we don't have file in scope. So we get red squigglies under that, and we can ask what's wrong. And not only can we, actually I should point out, if you're watching this video later, there's a little pop-up on the side that's going to show you all the commands that we're typing in, but I'm not going to read them out for now. It's just for your future reference. Okay, so we can say, well, what can I import? What can I import file? And we get a pop-up and we can select it, and it boots that import right up at the top. So you would expect this in any IDE, and now we've got it in Emacs. And we can ask for the type inference. Here we're navigating the type tree for what file looks like. We get all the methods and so on. We get autocomplete on methods and on the parameters that are in the methods, and we can use tab to jump between them. And we can jump to our tests. So we don't actually have a unit test for that particular file. We have integration tests. So it's created a new unit test for us from a template. I prefer flat spec, so that's what it uses. And we have some level of integration with SBT. So we're now running the SBT mode to say run just this test, just this one test, not the whole project. Of course that failed because we just have a fail no test. We're opening up another file here because I want to show you that we can jump back to the original test. So there are key bindings to jump between an implementation and the test corresponding to that. So that helps a lot with day-to-day navigation. Right, this bit's very cool. Did I just miss showing you that? Yeah, okay, I'm going to wind that back a little. So we moused over Q, as in the Scala immutable Q, and we jump into it. Oh, we're going to just have to replay that again. So what we did there, we actually jumped into the source code of one of our third-party dependencies. So this source file is in the Scala standard library, but we're able to go to it because Ensime manages all the sources of all of our dependencies. Back into our code, we can do the same thing with a Java class. So we're just going to go down to a file object here, which is actually a Java object from Apache Virtual File System. Oh, we jump in there, we're in Java, so we want to get out of this quickly. Back here. Okay, and typically with Java, you would look at the Java docs instead of the source code in order to understand what's going on. We can do that, so we ask, show me the documentation, and it pops it up in the browser. Same works with Scala docs. It's a shame nobody writes Scala docs, otherwise that feature would be much more useful.
Talk to Dick.
Yeah, talk to Dick. And everyone always wants to know about refactoring support. So here we're going to the parameter file on the method, and we're saying rename that to foo. And we get a little preview of what it'll look like after the refactoring. And we can say yes, and there we go. Every instance of that file has been changed to foo. We can mess up the formatting, and then we can ask for it all to be reformatted again, and that uses Scalariform. And that will use the same formatting rules that your SBT project Scalariform is using. Okay, and now we're starting up a REPL. There's nothing particularly special about the REPL at the moment, but we do have big plans for it. But I guess the most important thing about our REPL is that it's using the class path of your project. So once you open up the REPL, that's it. All of your stuff, all of your dependencies, they're all right there. Just very convenient. Okay, and final feature I wanted to show is search. So this has popped up a little real-time search bar, and we're going to use camel case searching. So people do this in IntelliJ and Scala IDE all the time. So we're looking for the letters FQN, and it's found straight away a class that we have called fully qualified name, and we're able to jump to that. So that's the end of the demo. Just a very, very quick whirlwind tour. Okay. Oh dear, it started the demo again instead of going to the next page. Okay, so let's talk about what was happening in the background of that, the architecture. So Ensime is a separate process. It lives outside of your editor. Emacs in this world is in a little box of its own, and it only communicates to the Ensime server through the Swank protocol. The Ensime server itself is living inside the dotted lines. And it runs locally, so it has access to all of your project's files and that .enzyme file that we generated before. We're not tied to any specific build tool. As long as you can generate that .enzyme, it'll work for you. Some people craft them by hand. And whatever client you have, be it Emacs or whatever, the entry point is the project class. And effectively all it does is delegate to one of the many components we have in the back end. So it's very extensible in that regards. We have a search service, so when we start the project for the first time, we go through all of your class files, all of your dependency class files, and we index them with ASM. And we use Lucene, so we're indexing that to have some nice natural language search, as well as the obvious searches like prefix and so on. And we're using H2 to persist that to a relational database, which allows us to do queries on that, more rigid queries. We also have the source resolver, which is the component that links the source files in your dependencies up to the binaries so that we have a relationship there. The doc server, which is hosting up the Java docs. It knows which documentation you want, hosts it up over Spray. A debug manager, didn't show that in the demo, but we do actually have debugging support, and we have to manage the state of the JVM. That's the component that manages that. But the most important bit is the analyzer component, and this is really just a front end that sits on top of the presentation compiler. And the presentation compiler is a part of the actual Scala compiler. So we haven't implemented any of that stuff ourselves. It's all straight from the Scala compiler. We're using the same compiler that's compiling your code. And we also have, there's a refactoring library that we're using to provide some of the refactorings, and the formatting as well, all provided by external things. We try not to re-implement stuff if there's something already out there that we can use. Okay, so that's the Ensime server, but it's worth pointing out this is not just one project. The Ensime server has its own repository on GitHub, but there are 3 different branches. We really have to maintain it that way because the API changes so much between major releases of Scala that we really need to maintain separate branches. But the Emacs code is on a completely separate repository, and the server doesn't depend on that at all. We also have separate repositories for the various build tool plugins, be it SBT or Maven or your own homebrew build tool. And we also have Docker images. So those Docker images have things like the official JDK that we want to support and the version of SBT and so on preloaded, which helps our CI. But one of the best things about Ensime is the community. There's been a bunch of studies recently. Benjamin McO'Hill gave one at LibrePlanet a couple of years ago where he analyzed all of the projects on GitHub and showed that the vast majority of open source projects is just one person. Whereas Ensime really is a community. It was all started by Eamon back in 2010, and it sort of petered off a little bit, but then a few more of us joined, and now there's 4 of us who have full admin access, and we're able to review pull requests and accept more people in as admins to the project. So it's very, very active. This doesn't give Eric enough credit because this is the Ensime server snapshot, and Eric tends to do an awful lot of work on the Emacs side. And just to show you, it's not just the 4 of us. This is a massive community. This is just a list of a bunch of people who've contributed to the server component, and a lot of people just come along. They'll raise a ticket. Sometimes they'll send us a pull request with a fix for that ticket, or just implementing a feature that's one of their bugbears. We might never see them again, but this is really critical to Ensime. We don't have financial backers. Our long-term survival is about people coming along, maybe just doing little bits and pieces, just spending one evening helping. And we have a completely different contributor list for the Emacs side because people have different interests. You might notice that Rory's name is quite low down there in terms of line count.
It could have been off the list if I'd tried harder.
Yeah. A little known fact is he doesn't actually use Emacs. So there you go. And what is this community that we're building? There are some principles. We have a code of conduct, and that's not in reaction to anything. We've just seen that it's a good thing. We've seen other projects put it in place, helps people feel comfortable, feel safe, and we've got really good vibes in our community, and we want to keep that up. We don't want anyone to come along and ruin that. So we've got some formal processes in place for that. We just completely stole it off type level, to be honest. And if you're a new contributor, you get loads of help. And basically, if you open a ticket, we'll probably think about it for 5 minutes and give you a link to the general area in the code base where you can make a fix. That's the way we do it. And if you do raise a pull request, the reviews will be fast. Maybe not hours, but you'll certainly get a response within a day or 2. And we give a lot of feedback, and we'll help through that whole process of getting it accepted. We really want to merge all the pull requests that we get, so we really will help there. And we take a very pragmatic approach to how we actually do the software development. Forget your day job. Your end user is not some business person or a non-technical consumer. Everyone that uses Ensime is a Scala developer. So we don't need to build in complicated logic to handle error cases or things where you might do that in your day job. Keep it simple. Prefer to fail and give a very clear explanation of what went wrong instead of introducing complexity to deal with it. That keeps the code base simpler, which means we can focus on new features and fixing bugs instead of having to always deal with the weird little corner cases if there's a fix outside of Ensime that will help. And we tried bounties. We used bounty source. There's about $1,000 worth of bounties on a bunch of tickets in the Ensime server. It was actually a bit of a failed experiment because people don't actually care about the money whenever they're contributing to a project like this. It's kind of very counterintuitive. We thought this would be quite useful, but actually most people who've come along, they've closed a ticket that has a bounty on it. They've told us they don't want the money. And we've had to basically force them to take the money and then put it on another ticket, just because otherwise it stays with bounty source. It's in a big black hole somewhere. Maybe we did it wrong. Maybe we should have put more money on smaller tickets or something. But it's kind of interesting. So another thing that we do to help the community is continuous integration. So helping automate as much as possible about getting your code into the main line, getting it out into people's machines. So if you send us a pull request, we don't use Travis or Jenkins. We had problems with them in terms of build stability. We're using something called Shippable, and they let you run Docker images, because we have our own Docker image. And on that Docker image, we'll run through our formatting rules, our unit tests, our integration tests, our Emacs integration tests, which people don't even know that we have. Often the first time people find out about them is when they get a red light on a pull request, which is brilliant, catches bugs early. We're looking at, there's a little icon up in the top right there of drone IO. We're probably going to start using that in the future. It seems to be the better way to do it. And we do coverage. So we're really keeping an eye on how much of our code is tested. And if the coverage drops, that'll actually fail the build. So we've got very, very high standards in terms of just standard process in place, automating as much of this as possible. So you'll get the immediate feedback from a pull request because of all of this mechanism that's in place. And because we have such strong confidence in our testing, when we merge a pull request, it will be built again and immediately distributed on Melpa for the Emacs front end or on Sonatype for the server back end. So as soon as it's merged and built, everybody who uses Ensime will get your code straight away. And that's worked out exceptionally well. Okay, protocols. So we mentioned about protocols before. It's worth mentioning this. Any sufficiently complicated program contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Common Lisp. And we are absolutely no exception. Our protocol is based on S expressions. And I'm actually running out of time, so I'm going to skip through a bunch of the detail on that and just get to the key point. So it comes from this thing called Swank, which is the protocol used by an Emacs mode called Slime, which was also an external program that helped Emacs to understand Common Lisp. So you would send messages out to that and it would come back with information about the function that the point was on and so on. And when Eamon set up Ensime, he thought, oh, well, brilliant, they've got a protocol right there. I'm just going to base everything on that. And there's a bunch of existing infrastructure, especially in Emacs, to deal with parsing the messages and so on. So we have this as our protocol. There's actually a bunch of really interesting benefits of using S expressions instead of JSON. You don't have to have keys that are strings. Your maps can actually have some ordering in them. JSON doesn't have that. And you can encode some structure where JSON maybe couldn't. So actually, although there's no official schema for either of them, it's actually probably superior to JSON technically. And just as an example, here's some domain objects. This is what the wire protocol looks like. So you can actually look at it and intuitively understand what's going on. And the way we implement that is with a standalone module within Ensime called S-Express. It's inspired by SprayJSON, which I think is a beautiful library. But we've got shapeless magic. Thanks, Miles. Which means that you don't need to write lots of boilerplate for your product classes. It's not as smart as it could be because I wrote this before Shapeless 2.1 was released. But we've implemented some of the better stuff in the next slide. The reason we do this, the reason why we have this all in place is because it makes it easier for people to contribute features. It means you don't need to implement your stuff, implement an endpoint, worry about marshalling, get it all right everywhere. You just write the feature, add an object in somewhere, and it shows up magically. So that's why we're doing this. But in terms of that particular protocol, we do have a backwards compatibility issue with Emacs. So we can't introduce break-in changes. Otherwise, we'll break everybody's client. That's why we have the integration testing. And JSON. Why JSON? So this is the big news here, I guess we've got to announce at this conference, is that we now have a JSON protocol. It's just merged a couple of days ago because most editors don't know how to speak Lisp. So this is going to make it, hopefully, a lot easier for all you people who are not using Emacs but not using IntelliJ, and you want support in Sublime or Vim or so on. Hopefully you can help with this. So if you build it, they will come. That's really what we're hoping. So we're calling this protocol Jerk because we're hilarious. And we're using Shapeless for that. And unfortunately, I wanted to tell you about how we're actually doing that, but I've concluded that it's a talk in its own right. So hopefully I'll give that talk at Scala IDE in December, some code. Right, but basically the big problem. Actually, I'll skip through to just the end game. So if you have a sealed trait and a bunch of case classes, case objects, and so on, you don't need to write any marshallers whatsoever for this. It'll work them all out for you. They're derived at compile time. They are ridiculously fast at runtime because they're completely derived at compile time. So you can just write code like this. So it really is magic. The one problem with it, though, is we have 50 case classes in our sealed trait for the incoming messages, and that takes about 20 minutes for the compile. And if you remember back to earlier, with Rory around, that could be quite fatal for me. And at this point, I'm going to hand over to Rory, who is going to talk about performance.
Cool, thanks, Sam. So I know nobody likes waiting for Scala compilation, and especially when you do clever things, that can be a bit of a pain. So actually the first thing on my personal roadmap, performance is a problem. So Ensime is a shim over the presentation compiler at the end of the day. So a lot of the work is actually done within the Scala compiler, which means if the Scala compiler is slow at compiling complex types, we're slow. And especially on an interactive system, and you'll see it if you've used Eclipse as well, is occasionally it will pause because it's stuck trying to work something out. So one personal example, which is something I was working through with Miles, which is one of the methods which is called quite a lot when using strings in types, is this method, and it creates a combinatorial explosion of results to generate a single result string. So all the way down it's string buffers, string concatenation, and repeated. So I've promised both Miles and Sam that actually my next target, the thing I'm going to be focusing on over the next few months, is actually trying to look at things that are hurting us within Ensime, but also within sort of Shapeless and some of the bits, and try and find some of the sort of low-hanging fruit in terms of performance, and hopefully we can get some items into the mainline. So our next big target is the 1.0 stable release. We've done a lot. We've tried very hard to do continuous release, sort of continuous deployment, continuous release, and it works pretty well. As long as your continuous integration and your testing is tight enough, you can actually release regularly without breaking things very often. But what we found is people who work in corporate environments behind firewalls where stuff doesn't update, your resolvers don't work, it's a pain. So what we're actually going to do is we're going to separate out the compilation into a sort of stable release, which is released on a cycle with proper versions, and sort of the bleeding edge snapshot releases. And that also gives us some freedom. So we can then break compatibility. We can rework some of the protocol stuff to make it simpler. And the other big thing is what will be released in 1.0 is a JSON WebSocket interface. So at the moment, it's a socket using Swank. And we're hoping, as Sam said, that will give us a lot of ability to onboard new editors with a lot more ease. You don't have to go and rewrite a parser. So just to show you, this is a waffle board. So we try and make everything we're doing and everything that's on the list public. So please go and have a look. This is all of the remaining tickets for 1.0. Most of them are trivial tickets. There's a few bug fixes. And then we're going to release, so hopefully within the next sort of short while. After that, what's the big focus? Simplification, both. As I said, on the protocol layer, we can start to take out methods and combine methods where it makes sense rather than being tied to the current protocol layout. Both within the core of Ensime. Ensime's a bit of a mishmash. It has actors in places, it has threads in places, and within the protocol, as I mentioned. So designing for enhancement, we think this is vital. So everybody talks about documentation. Dick talks about documentation. If we want people to contribute, you need documentation on how to contribute. You need documentation within the code. You need the code to make sense just by looking at it. So I've worked hard to ensure that silly things like method names make sense. I want the intuitive understanding of the code to be what it's actually doing. Going reactive, as I said, we've got threads, we've got a real mishmash inside the application, and we're looking more about more actors, more reactive, right through from the protocol layer. The protocol layer is currently a blocking thread, goes to an actor, goes to a blocking thread in the presentation compiler. It's all a bit of a mishmash. One of the key features that Ensime doesn't have, which I actually miss whenever I try and use Ensime, is a reverse lookup. Who uses this symbol? Who uses this method? Who's looking at this var? And yeah, so that's very high up on our list. And interestingly, Ensime support, or Engine support. So this is supporting of Java within a Scala project. So a lot of people do have mixed projects, and currently Ensime really does only support Scala. You can use Java libraries, because at the end of the day it's all bytecode, but you can't really edit it in the same way you can with a mixed project. So the fun bits, the future, where are we going after this? What's our big vision for Ensime? More editors, Sublime. I saw Dick shake his fist in joy there. He will have to help. I think that's the deal there. So did everybody hear that? Dick said he's going to fix. You notice we haven't given any deadlines either. It's all volunteer time. Atom. So Victor's been doing some work. Where is he? Hello, Victor. Victor's been doing some great work so he's got a prototype of Ensime backing Atom. It's very exciting. I think someone's been editing my slides. So there is actually, or was actually, an Ensime plugin for Vim called VimSide. It's out of date and fundamentally broken at the moment, but we have had various promises that people are going to look at it. And I think is another interesting one. I know a lot of people do actually use Vi for editing code.
I suspect that there's actually some crosstalk between Sublime and VimSide, because I think they start working around the same time.
Yeah, so
I suspect they're facing similar problems.
actually, getting either of them working off the cuff is actually not that hard. It's one of the things we have actually broken is how you launch the Ensime server. So there's some tweaks around that. So actually, in the 1.0, the protocol itself hasn't changed very much. So getting those two running again shouldn't actually be that much work. And your edge here, as we said, we want people to integrate with this stuff. We're trying to make it easy. If it's not easy, come and beat up on us, raise tickets, come talk to me, email me. You know, what do we need to give you to make your life better? So, as I said, Victor has been working to get completely randomly. We came up and Victor bumped into us yesterday and said, you know, yeah, it's sort of working. And we said, give us a demo, we'll put it in the talk. So here it is. So this is Atom actually doing a lot of the syntax highlighting and so on based on Ensime. There's a bunch of really cool stuff coming, and actually it's really inspiring to stand at this talk at the conference, because Tasty, Scala Meta, and SBT Remote gives us a whole bunch of interesting possibilities, you know, and using those to improve Ensime and improve the underlying tooling is awesome. I'm actually really quite excited about it all. So one of the things that got me into Ensime when I started was not actually Ensime for Emacs. It was the fact you can use Ensime to ask questions about code. It's a user level API over the compiler. So I can say things in a much more natural, you know, what's this method, who implements it, etc., rather than having to deal with the AST directly all the time. So why would you use that? Analysis, tooling. So one of my bugbears is Sam and I have had the joy, and Miles actually, of working on a 300,000 line project where I reckon 200,000 lines of that is actually dead. But actually finding the right 200,000 lines feels like a job for a computer rather than for me. So by having a higher level API, you potentially ask these kind of questions. And refactoring hints. So a lot of this crosses over. It's really interesting watching the Scala Meta talk yesterday about doing the refactoring at that level. They did a nice refactoring actor demo. And so, all of this is up in the air. It's all things we would like to do, but it's all possible. So this is my big thing. I actually think that Ensime should build its own IDE. Ensime is a fundamentally different model from the current compilers or the current IDEs, because the IDEs tend to be monolithic and they tend to be tied to the underlying platform. So IntelliJ is tied to their underlying data model and it's tied to the GUI. So you can't really separate that out. And I would just actually say that's true of Eclipse as well, having played with it. It's a layer over the Java one, beating the Java one into a Scala shape. If you disagree with me, come and talk to me at the end. How? So I think it's really interesting. I think we're at a real nexus point. We have a whole bunch of really cool technology. How would I build an IDE? Now, I accept that building an IDE is a non-trivial task. It's a huge thing. Why would you build it as a shim over Eclipse? Because building text editing on its own is hard. But this stuff exists. So what would I do? I'd use Atom and Scala.js, or actually ACE, the underlying editor that backs Atom. So it's a JavaScript component. Wrap it in a type-safe Scala.js wrapper. You're glad I didn't choose Swing. We're all glad we didn't choose Swing. Shared marshalling. So I actually think this stuff is voodoo. Right? So I have Scala.js and a web browser on one side. I have a Scala process on the other side. I have Shapeless and a jerk protocol doing marshalling. It's literally the same code. And I just find that, and all the marshalling's done automatically. And I find that really, I don't know about anybody else, but I find that really funky. An Ensime-based server, I would actually suggest you start Dockerizing these things. Put it in a box. Instead of having to... how many people here spend like 3 hours when they start a new project trying to get just the build environment and their project and their SBT build, everything running? A lot of us. So I think you can start to automate that. Let's just build a Docker image for Scala 2.11 or 2.12 that's just ready to go. The other interesting thing is we're starting to tease apart these components. So I actually think instead of necessarily having it all on one process, on one big machine, you end up using remoting, so SBT remote. So we have a compile node actually doing compilation in the background, a REPL, a node running testing, a node running your debugging, and potentially even coverage. So behind the scenes, I can now scale this out onto the cloud. So I've mentioned this briefly. Project separation. I think you should have each of your projects contain a separate Docker instance, personally. It means you don't have any of the cross, oh, I've got the wrong version of Scala on my path, blah-de-blah-de-blah. We've all done that. Remotely hosted development. So I no longer need to have my IDE on a big box under my desk. I can have a web browser on my desk and a big server that I can rent by the hour somewhere else, if that's what I want to do. And this is interesting. How many people have done remote desktop into work to do development? Lots of people. How painful is it? It's the only way they'll let you do it at Google. A lot of places, it's the only way you can get to a machine that you can actually use. But actually just typing code into an editor is just a world of pain with latency. I hate it. So when you separate out the two concerns between editing text and doing the grunt work, that difference disappears. Scalable, as I said, you can now fire nodes up. I can fire entire clusters if I want to do for my testing, and it doesn't have to live under my desk. Collaboration is another key point. So again, instant project setup. You can just start from nothing and be up and running in no time at all. I can point you a Docker image and you can be running your project. Now, Dick mentioned this to me, and Dean mentioned this to me as well. At the start, when you're giving an 8-hour workshop, you spend the first hour getting everybody up and running to the same point where they can all actually compile and run the application. If it's anything like Spark or something bigger, it can be a world of pain. Imagine literally being able to point people at a website, they get their editor, and they're going. Onboarding. I always think it's surreal that as a contractor I go and work, I get a 6-month contract at a company, and it takes 2 weeks before my machine actually works. You know, I'm sure everybody's faced that. The other thing I think is really interesting is the potential for collaboration. So with the separation of concerns, we can instead of having to share a desk, we can actually share the underlying infrastructure, which means you could have 2 cursors on the same editor. You could do some interesting, funky stuff. And I don't know all the possibilities that opens, but I think it's an interesting thing to explore. Other possibilities. So I love the Scala JS playground. I think it's really funky. You know, go and type some code, see what it does. With a backend, appropriately boxed backend, you can do the same thing for Scala. They sort of did it a bit with the online Scala courses at Coursera. So it goes and runs your code somewhere else. But in fact, I think I want to make that so you click a button, you've got a Scala editor, you can run your code. Activator sort of does that, but you've got to do a lot of work to install Activator. It's been minimized, but I think you've still got to have a lot of setup. Has anybody come across foreclosure? A few. So foreclosure is sort of like graduated programming exercise. If you're trying to learn Clojure, it's sort of like the first exercise, you put code into the web browser and it validates whether or not you succeeded in a task. So doing that in Scala at the moment, again, you would need to offload it, and you've got to build a lot of infrastructure. With the infrastructure in much more componentized form, you could potentially build that a lot faster. And that's, I think, a really funky way to get people playing with Scala. Crowdsourcing, the idea of just, I want to set up a project, I want to give us all a shared infrastructure, I want to build things. I think there's some really interesting ideas in that space as well. So, final thoughts. Ensime is a community project. You know, I know we harp on about it, but it really is powered by everybody. Please come and play. It's fun. We try and make it as fun as we can, and if we don't, please beat us up for doing so and go and point us at our own community guidelines. And I think it opens up a bunch of really interesting possibilities about what you can do with Scala and editing, and sort of where code editing is going, rather than it being what is effectively glorified text editors at one level. So, that's it. So, open for questions.
What is the current state of the Sublime technique? Because I know there was one that I think is broken now. Do you have any information about that?
It is currently broken.
It hasn't worked in a while, and even when it was working, it didn't support things like multi-module. It's never been great.
So I think Dick summed it up quite well there. It's currently broken. Getting what's currently there running, excuse me, shouldn't be that much work, but actually getting it to support the full gamut is probably quite a bit more work. But talk to Dick, he's on the list for doing that.
But actually, the multi-module thing, we fixed that on the server side. That wasn't a client-side problem.
Okay.
So if you can get it working, it will support multiple modules.
I think one of the other challenges with Sublime is there's something funky about the way it does tooltips and pop-ups.
Right, okay.
So that might limit what you can do.
Yeah, it's a client problem.
Yeah, so that is one of the challenges we've found is if your editor doesn't support sort of dynamic pop-ups being fed by a third-party API, then you're stuck, right? The best I can do is give you a list that you can try and work from. Any more questions?